Have you ever wondered how the universe is still expanding? How a radar gun can detect the speed of moving objects? How the change in blood flow is measured? How the bat finds its prey? How the meteorologists forecast the weather? To understand the science behind this, we have to understand what is Doppler effect. In 1842, Austrian physicist Christian Doppler discovered the Doppler effect. The Doppler effect has various applications in the real-life technology. Today, it is used in astronomical measurements, in radar and modern navigation, in studying motion of objects, in medical field, and so on. Doppler effect or Doppler shift describes the changes in frequency of any kind of sound or light wave produced by a moving source with respect to an observer. For instance, waves emitted by an object traveling towards an observer get compressed. Here, the frequency of the waves increases, leading to a higher pitch. Conversely, waves emitted by a source traveling away from an observer get stretched out. Here, the frequency of the wave decreases and the pitch comes down. Do you want to hear the example of Doppler effect? In this example, as the train approaches the observer, the sound of its horn is heard at a high pitch. That is, the sound waves produced by the horn is at high frequency. And as the train moves away from the observer, the sound of its horn is heard at a low pitch. That is, the sound waves produced by the horn is at low frequency. In astronomy, the source can be a star that emits electromagnetic waves. Doppler effect occurs as the star orbits around its own center of mass and moves towards or away from the Earth. Here, when the stars come towards the Earth, the wavelength decreases. This is called blue shift. When the star moves away from the Earth, the wavelength increases. This is called red shift. Scientist Edwin Hubble found that the light from distant galaxies was shifted towards lower frequencies, resulting red shift. Hubble used the Doppler effect to determine the universe is still expanding. Doppler effect are used in many fields besides astronomy. Do you know? Speed guns use Doppler radar to measure the speed of moving objects. Radar speed guns consist of a radio transmitter and receiver. They send out a radio signal in a narrow beam, then receive the same signal back after it bounces off the target object. Due to Doppler effect, the frequency of the transmitted wave and the received wave is different. When the object is approaching the radar, the frequency of the received waves is higher than the transmitted waves. When the object is moving away from the radar gun, the frequency of the received waves is lesser than the frequency of the transmitted waves. From that difference, the radar speed gun can calculate the speed of the moving object. This radar gun is also used to measure the bowling speed in cricket, speed of pitched baseballs, speed of tennis serves, and so on. Do you know one thing? That even in the medical field, the ultrasound technique works behind the principle of Doppler effect. Doctors use ultrasound to diagnose conditions of heart, blood vessels, liver, gallbladder, kidneys, and so on. In ultrasound technique, transducer can both emit ultrasound waves as well as detect the ultrasound echoes reflected back. When used in an ultrasound scanner, the transducer sends out a beam of sound waves into the body. The sound waves are reflected back to the transducer by boundaries between tissues in the path of the beam. Using the speed of sound and the time of each echo's return, the scanner calculates the distance from the transducer to the tissue boundary. This is how it works. Today, the Doppler effect even have applications in dynamic real-time path planning. It is a term used in robotics that consists of motion planning methods that can adapt to real-time changes in the environment. Bat find its prey using this phenomenon. Water current velocities over a depth range is measured using this phenomenon, and even meteorologists use this technique to predict the weather. It seems the Doppler effect is a versatile concept indeed with many useful applications. Can you think of any other one? I hope this video remains informative to you. If you like this video, give a thumbs up.